Hello and welcome to today's mathematics class. In today's class, we want to solve this question on integration. Look at it here. It says integrate 1 all over x plus the square root of x dx. So when I look at this question, I began to wonder which method are we going to use now? Yes, of course, substitution method. Substitution method can work here. But before we do that, we must look for a way to manipulate the denominator. Let us manipulate this denominator. We will have to factor out something so that at the end of the day, when we use substitution, we can be able to eliminate one of these denominators. Now, what do we need to do? Remember that in mathematics, if I said the root of x times root of x, you see the setting as what? X. That is solved. Good. Which means here, I can have a root here to multiply this root x here, to multiply what I have here. So here can be root x times root x. Then you still give me what? X here. Nothing has changed. So which means I'm going to express it like that. Let us express now. So to now give us the integral 1 all over. We are going to factor out. If I say root x here times root x, you see the setting of this root x here. Then plus root x, then the x here. Are you seeing that now? Good. Now, at this point, now let us factor out what is common. Factor out root x here. So if I factor out root x here, I'm going to have the integral, then 1 all over, or you can simply put the x there, no problem. We will now have what? Root x outside. Then we can have 1 plus root x or root x plus 1. See the setting. So that we now have what? 1 plus what? Root x. Then we have the x. 1 plus root x or root x plus 1 is still the same thing because addition is commutative. So from here, we can let u be equal to what we have here. This one we have in the brackets. We can say let u equal to 1 plus what? Root x. So that when we differentiate with respect to u, we differentiate the u, the x equal to, if we differentiate this one is 0. Now let us differentiate here. This one is sitting as saying x raised to power. Sitting as saying x raised to power half. Okay, minus 1. Right? Then multiplying by that what? Half. So we are multiplying by that. Which now give us the u, the x equal to what? 1 over 2. Then we have x is over negative 1 over 2. So at the end of the day, if we take the reciprocal, because we are going to eliminate this one, it will give us 1 all over 2 x raised to power 1 over 2. Yes, that is because this one is a denominator. If we take one again, because this will multiply that. Now remember, this one is what? Root x now. X raised to power half is root x. So that we have the u, the x equal to what? 1 all over 2 root x. Now we want to make du the subject of formula, or you make the x subject of the formula, no problem. See that you cross multiply, you say du equal to what? The x multiplying the whole of this one here, no problem. You can see what, use it. But let me do it in a way that somebody will understand. So if I cross multiply now, I'm going to have the x here. The x, cross multiply the x with times this one to give me equal to what? Du times this one, have 2 root x multiplying du. Good. Now let us go to this our expression now. We are going to use this one. We are going to substitute for the x here. So that we now have there 1 all over root x now. So the whole of this one here becomes u. Okay, that's your u. Then multiplying by what is your dx now? The x is now replaced by this. We have multiplied by 2 root x. Then du. Good. Now we can cancel out root now. So this root x and root x can take care of each other. We can have this one, have this here. Or simply, will now become the integral of 2 all over u du. This is what we are going to have now, because this one and this one is already cancelled out. Then you can bring out these two. Since this one is a constant, bring it out to become 2, then u, that is 1 all over u now. Okay, sorry, becomes 1 all over u du. Let's go. And remember, the standard integral for what? 1 all over u to give us the ln. So we're having 2, the integral for 1 all over what? U, then du. And we have a standard integral for that. It becomes what? 2 multiplying the ln of what? U. Okay, then plus constant. And of course, remember that what our u is equal to 1 plus what? Root x. So that we now have what? 2 bracket what? Ln, to the ln of what? 1 plus what? Root of what? X. Sorry, the root of x. Then plus what? C. So this is our answer. This is how we integrate this kind of problem. I hope you find this class interesting. If that is true, help us to share. Just hit that like button. Hit that like. And also share. Bye.